You just start at C and you go to the nearest neighbor every time. So starting here at C, you have it on your handout there. Starting there at C, oops, it's not the color I wanted. Okay, starting there at C, you just say, okay, I'm going to make a trip visiting a tour, right? Visiting all the cities, always taking the lowest path every time. So you got it on your handout there. So what would be the lowest path from C? You all got it there? C to D, right? C to D for 20. Everybody with me? C to D, and then next, where would we go from D? What's the lowest path from D? Is everybody tracking with what I'm looking at? Yeah, so I'm at D right now, so where would we go? It'd be E, wouldn't it? E for 34. That's the lowest number, right? And now from E, it's either going to be A or B, because those are the only two cities left we need to travel to. Which one is it, A or B? B. Yeah, B for 26. Go to B. And then finally, once you're at B and you only have one city left, don't worry about the numbers. You've got to go to that last city and you got to go home, right? So it's C, D, and notice how I'm writing it out, guys and gals. As I go, I'm just saying C, D, E, B. And now, I don't even need to write the map anymore. There's only one city left. I've got to go to A, and I've got to go back home to C. So there it is, and that's the answer. That the green one is the right answer. C, D, E, B, A, C. C, D, E, B, A, C. Does that make sense? On these handouts, don't worry about where it says you answered. I gave a bunch of wrong answers. But you can see the right answer is on there. It's B. Is that good on that? Nearest neighbor just means start at a point and go to the nearest neighbor every time. Part B says now do the nearest neighbor starting at D. You get the idea. Can I just skip through it? That okay? And so let's take a look at number 2. And basically it says choose the correct repetitive nearest neighbor. Oh yeah, let me. Okay, so here's number 2 now. Now what repetitive nearest neighbor means is they want you to do nearest neighbor repeating from each of the points and then pick the overall winner and rewrite it at the end starting with B. Okay, here's what I mean. Let's start at A. So we're doing, let me write it up here. This is problem number 2 and we're doing repetitive nearest neighbor. Oh, by the way, all the grades are updated on Math Excel. Did y'all see that where the results are? All the homework, all the quizzes, everything's updated. If you have any questions, grab me. If this is not the right class for you, if it's just too crazy fast, whatever, today's the last day to drop. We're halfway through. Or tomorrow, I guess, technically. Right, we're halfway through. If you drop now, you get a W. It's not in your transcript. Does count as a failed attempt, though. But you won't get a letter, grade. After tomorrow, it's letter grade. So, if you're in or out on that. So we have 3 more exams to go. You can improve your scores, definitely. Lots of points left. Math takes time. Some did great. Some didn't do as well on this exam as the first exam. Math, you got to spend lots and lots and lots of time working through these problems. Aaron's available. There's help. He's there every morning, 10:30 to 2. Right? Is that right? Yeah, Monday through Thursday. Every morning, 10:30 to 2. Our tutor, Aaron Cuevas, he's over in the tutoring center. Get the help you need. Get the help you need. Go over those practice exams again and again and again and again. Everything on that test was just like the practice exam, just different numbers, different particulars. So do what it takes to master this stuff. All right, repetitive nearest neighbor. So what that means is you do nearest neighbor 5 times, starting from every letter. So it's nearest, well, it just means, okay, let's start at A. So here I'm going to start at A and do nearest neighbor. So starting at A. Who's my lowest number from A? Or which letter am I going to go to? C. It looks like C, doesn't it? C this way at 3.3. So I'm going to go to C. Keep the total. 3.3. This time we got to add them up because we're going to do this 5 different times and take the overall lowest. It's 3.3 to C. Now from C, what's the nearest neighbor? It's going to be that 2.4, right? To E, which was 2.4 for that road. Y'all with me? I gave you that handout so you can follow along. Does it make sense what I'm doing? And then from E, there's only 2 cities left to go to, either B or D. D, right, for 2.6. And once you've gone to D, don't waste your time. There's only 1 city left. You've got to go to that city and you've got to go home. So you got to go to B, which is what, 4.0. And you got to go back home to A. From B to A is 3.5. So add that up. What is that? 5.7. I can't add that up. 7.7. 8.3, 12.3. Is it 15.8? You guys add it up, let me know. So that's just starting from A. Now I got to redo the whole thing starting from B, and then starting from C, and then starting from D, and then starting from E, and pick the overall lowest. That's what repetitive nearest neighbor means. Repeat nearest neighbor for every starting point. It's good so far? You guys see what I did there starting from A? I just went to the closest neighbor every time, starting with A. Now I'm going to redo it. I'm going to start at B. Well, I'm not going to use that color. You won't be able to see it. Let me see. I'll do a yellow. So starting at B. So I'm going to erase what I did with A. Now I'm going to go back and start at B and do repetitive nearest neighbor. So start at B and go to your nearest neighbor. Who's your nearest neighbor? From B. It is A. Everybody see that? 3.5 to A. B to A, 3.5. So I encourage you to write this down as we're going. From A, who's your nearest neighbor? 3.3 to C. From C, we've either got E or D. We only got 2 cities left. Oh, E by far, huh? E is the 2.4. And then we've only got 1 city left. Don't waste any time. You've got to go to that city, D, 2.6. And then you got to go home back to B. At least on this one we started at B, back to B, which is a 4.0 trip. Well, that looks pretty cheap. 6.8, 8.8, 9.2, 11.8. Oh, I got the same total. Oh, okay. Maybe it's the same loop. Is it the same loop? No, it's a different loop, I think. Oh, no, it is the same loop. How do I know it's the same loop? Look at the letters. Start with A. A, C, E, D. A, C, E, D, B, B. It's the same loop starting in a different spot. It won't always be. Sometimes you get different loops. But see how that's the same? See, remember, you can rewrite any of these starting at any point in the loop because they're all circles. You can start anywhere in the circle. In the end, they want us to take the overall winner, the best answer, and rewrite it starting with B. Do you understand that's what they want us to do at the end? That doesn't mean the real answer originally started with B. It just means that's how we're going to write the final answer. Everybody see that? That confuses a lot of people on the test. They'll only start with B when they look at those answers. They get fooled. I don't want you to be fooled. I'm not trying to fool you. Does that make sense? So now start at C. Do the same thing again. So starting at C, go to your nearest neighbor. Who's the nearest neighbor from C? Starting from A, you could go 4.3, 2.4, 3.3, or 3.6. Remember, it's not nearest like closest, it's lowest number. I mean lowest number, so it's the 2.4 road, huh? To E. Does everybody see that? It's 2.4 to E. 2.4, and then from there, what's the lowest number? From E. Yeah, it looks like D. 2.6 to D, huh? And then from D, we only have two options now. It's either going to be A or B. Which one of those is lower? A is 3.4. And once you're at A, you have no choice. You have only one city left, right? When you have only one city left, you got to go to that city, go to B for 3.5, and then you got to go home, which is back to C in this case. C is where we started, which is 3.6. Okay, what's that total? Is it 15.5? Let me know if I added that right.
Yeah.
Okay, thank you. So that one's a little better, isn't it? Little shorter overall loop. Now let's go again. This time I'm going to start at D. It's pretty tedious, this nearest neighbor. This is the longest of the methods. Now do the nearest neighbor starting at D. If I start at D, who's my nearest neighbor? Who's the lowest number from D?
E.
At D to E. 2.6. And then from E, at 2.4 to C. Starts out really low here. From C, I'm either going to go to A or B. Which one's lower? A at 3.3. It's lower than B. And then once you're at A, you have 4 cities. You only got 1 city left. You got to go to that city, which is B, for 3.5. And then you got to go home. Where's home? In this one, it's D. Back to D, which is a 4.0 road. So add those up. What's that? 5, 8.3, 11.3, 11.8, 15.8. It's probably the same loop as those first two. The total's the same, 15.8. It is. Do you see how it's the same loop backwards? A, C, E, D, B. Just go backwards. It's the same loop, run it backwards. It's the same loop as the first two, it turns out. We good to there? One more. We're almost done with this one. Start at E. Last one. Starting at E. What's my nearest neighbor? From E.
C.
Oh yeah, I was going to do D. Yeah, it's C, huh? Yeah, good. C. That's 2.4. And then from C, where do I go from C?
A.
Yeah, it looks like A, doesn't it? A for 3.3. So now it's either B or D. Which one's cheaper? D is a little bit cheaper, barely. Go to D for 3.4. And finally, once you're at D, you only have 1 city left. You got to go to that city, B. So from D to B is 4. And then you got to go home. Home in this case is E for the big 4.7 road. That's not good. So this one looks high to me. I don't know, 5.7, 8.7, 9.1, 13.1, 17.8, unless I added that wrong. All right? So who's the winner? The winner is, for all that, the winner is this one. This road here. The nearest neighbor that started with C, but we can't express the answer that way. We have to rewrite the answer starting with B, because that's what they asked me to do, right? On the problem, didn't they say that? They said rewrite it. Correct, yeah, choose the correct one starting with B. So start it with B, So start here at B. It's just a loop. You can start anywhere in the circle, right? Start at B and go B, C, and then come over here. E, D, A. E, D, A, and then of course back to B. There it is. That's the best answer that we can get using this method called repetitive nearest neighbor. That doesn't mean that's really the best overall answer. There's probably a better loop out there. But that's the best one we can get using this particular method. Is that what was on the answer key thing? Or did they have it backwards? Sometimes they're listed backwards. Oh yeah, it's backwards. Do you see how, as you look at the options, let me show you. Yeah, look at the answer options. It's actually this one, but see how I had it the other way, right? I had it B, D, E, C, A, B. It's the same loop though. Will you recognize that on the test next Wednesday? That fools a lot of people. Let's hold on one second. So this is the answer I just got back here, right? B, C, E, D, A, B. Oh no, that's not the same answer. I'm confused.
You didn't check the answer, so that might not be the right one.
Oh, maybe you're right. I guess I get the wrong answer here. What is it? B, D, is it even there? B, A, C? B, A, C. Wait, I'm confused. What's the right answer? It's B, C, E, D, A. 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 Back to B. Okay, that's the right answer. B, C, E. Oh, it's right here. It's this one. Yeah, I guess I didn't check the answer. It's B, C, E, D, A, B. I never finished this. So sorry, watch out. It's got the wrong answer on there. It's the second one down, right? It's not this one. You with me? It's right there. That's the answer we got. But watch out, it could be forward or backwards on the multiple choice test. That fools a lot of people, right? They have the right answer, but they don't recognize it's listed because they could also list it going this way, right? It's the same answer, B, A, D, E, C, B. That's the same answer. It's the same loop going forward or backwards, right? It's the same way of visiting the city. Same roads, all the same roads, total cost is the same. Okay, now hold on. Here's what I've seen. I've talked to students who've done poorly on this third exam we're going to take next Wednesday in the past, and here's what they do. They don't really know what they're doing, and so they think they can come in here and just add these up. This will not work. They come in and they think, okay, look, I don't know about all that stuff Ms. Heron was saying about da-da-da-da-da. I can just do this map thing, right? B to C to D, I'll just count it out. B to C, that's 3.6, and to D, and then they just add them all up, you know? Just add up the answers. First off, it takes them forever. Well, of course, this problem takes us forever, too, but some of the other ones are quicker. They add them all up. Say this comes out to, like, I don't know, 15.1. What was ours? Ours was 15.5. The real answer was 15.5. Maybe this is 15.9, and this is 16.3. And they go, oh, this top one's the lowest. I got it. It's got to be that answer. No. Even if that one is lower, that doesn't mean that's the answer to the method called repetitive nearest neighbor. Are y'all getting that? Let me say it a couple times and make sure that concept sinks in well. This is a method. We know this method doesn't necessarily give the best overall answer. There is probably a better answer out there. Maybe it's even one of those. But the question asked you was use the repetitive nearest neighbor. Using that method, which one is best? Not what's the overall best, right? So you can't just take the answers and take the best one. Plus there's none of the above option too. But anyway, that's just not going to work. Does that make sense? We're going to have different ways of doing these problems. And there, again, one of the main points of this whole chapter is these methods are not perfect. UPS and FedEx would pay big bucks to anybody that could come. They still don't have one. It's still unknown. The search is still on. They don't have a perfect method. Remember, we tried the computer thing? Computer take 800 years or whatever it was to look at them all. And so these methods we're going through are pretty good, but they're not perfect. In fact, I'll write out terminology for that within the hour called optimal. They're not optimal. They don't guarantee the best answer. There's probably a best answer out there. It just takes too long to find it, right? We don't have 800 years for a computer to look at them all. So Everybody getting that idea? Just because you find one lower doesn't mean you should choose that option. There are better answers out there, sure. But this is the best thing that this method produces. So y'all with me on the methods? That makes sense then? You have to literally do that method, which is nearest neighbor, start at A, start at B, start at C, start at D, start at E. Take the lowest of those 5. Yeah, the lowest of those 5 is the right answer. But not just the lowest of any loop anywhere. Make sense on that? Okay. So let's keep going. If you're okay, I'm going to move on. Yeah, so starting at A. So I guess that's the real answer. So how much is that tour? Starting at A, from A to C, let's go over here to the map. From A to C is what? 185? It's 185. And from C to E is what? 340? 340. And from E to D, so they go this way, E to D is 305. And from D to B is 165. And from B back to A is 205. So if you add all those up, add it, add it, add it, add it, I don't know what it is. 1,200 equals 1,200. That's miles. And remember, it costs the band $8 per mile to rent the charter bus. So then you got to take 8 times the 1,200, and that's how I got the $9,600 for the trip. Does that make sense? It's just multiplied by 8 at the end. So once you do it's repetitive nearest neighbor again, which is really long. I don't want to do that again. But you got to do the repeat. You got to start at A, start at B, start at C, start at D, start at E. Take the overall winner. This must be the winner. And then multiply it by 8 at the end, because it's $8 per mile to get the $9,600. Cheapest trip for the band to visit the 5 cities. At least the cheapest one they could find using this method. There might be a cheaper one out there. Is that good? Is that okay? Questions on that? Anything I can answer? All right, so repetitive nearest neighbor on that. Methods. Okay, so cheapest link. How do we do it? And I'll write all the methods out in a minute to be clear with you. But basically, it's just nearest neighbor, starting from only one point. It's repetitive nearest neighbor, like do all 5 nearest neighbors. And then lastly, cheapest link. This is the last method. Okay, how does it work? Basically, it's pick the cheapest road or link, each time. Well, I'm not saying that very well. Pick the cheapest link anywhere on the map each time. So in other words, it's not starting, let me just write that, not starting from any particular point. Does that make sense? So we're just picking the cheapest road, and we're like, look at that whole map. What's the cheapest number up there? What's the lowest number on that entire map? What's the lowest number on that entire map? The 155, right? So that's the first road we're gonna say, hey, whatever. We're making a loop to visit all the cities. So, hey, if we want the cheapest one, just grab that road. Notice I didn't look any particular place. What's the next cheapest road up there? What's the next cheapest? Can you all tell? So 155 is first. Which one's next? Looks like that 180, huh? 180, we good? Even though those don't connect, even though those don't come from any certain city, see this method? I'm just going to keep picking them until they form a loop. So that's the cheapest link idea. You just keep picking roads anywhere. See how that's different than nearest neighbor plan? The nearest neighbor started at a particular city, and just from that city, what's the cheapest road, right? Whereas this says, hey, look at the whole map, and just pick the cheapest road, the next cheapest, the next cheapest. Just keep picking roads until you make up your loop. But there's a couple of exceptions, because we can't pick any old roads. There will be some problems. Here's the big no-nos. Well, I don't, not the father. There's two nots. Number one, do not make a loop with less than all cities. Right? Don't prematurely make a loop. Do you know what I mean by that? Like, what if I said, oh, here's a good road, and here's a good road. There we go, we're done. Well, no, we never got to city D. Even if those other two were great links, and they were the cheapest two, they aren't, but suppose they were, you know. I would take them, I could not take those two next, even because you'd never get to say, oh, that's okay, then just eventually get to D. No, that's crazy. You're not, that's not even a loop. First off, we're making a loop, right? That wouldn't even be a loop. So do you see the problem? So you can't make a loop prematurely, meaning a loop that has less than all the cities. Do not make a loop with less than all the cities. So as you're picking your roads anywhere, make sure you don't close a loop with less than all 5 cities in there, or however many in your problem. Right? Remember, we're making a loop for all the cities, right? We got to visit all these locations. And number 2, do not have 3 roads hitting one city. Right? We only have 2 roads. When you finish making a loop, think about it for a minute. Every city is only going to be hit by 2 roads. One coming into the city, one going out of the city. I would never want to pick like those 2, for example, because that would be 3 roads hitting B. That's never going to work for a final map. Only, you know, when you're done with the loop, you just have 2 roads hitting a city. The one that's coming in, the one that's going out. Not 3. So as long as you avoid those 2 no-nos, don't make a loop too early, loop with less than all the cities, and don't ever pick 3 roads hitting one city. As long as you avoid those things, just keep picking. And just keep picking the cheapest, the next cheapest, the next cheapest, the next cheapest, and eventually, as long as you avoid these 2 no-nos, it will make a loop. Now, again, it will not necessarily be the best. It seems like it would be. It's not, because sometimes you'll skip really cheap ones to do it. So again, this does not guarantee the best answer in the whole world, but it guarantees a fairly good answer. So does that make sense? Shall we try that? So watch out for those 2 no-nos, and let's give that a go. So back to it. So they tell us to do cheapest link. This is problem number 4, right? Number 4, okay. The rock band thing. All right. So cheapest road, we already did. It's the 155. Here's what I encourage you to do that'll be really helpful for you. Right on the side. It's not a big deal on this one, but I'm going to give you one in a little bit that will really help. I started doing this with students years ago, and it helped them a lot on the test. Write your links. So that was an A-B connection. I mean, I know it's on the picture and everything, but it'll help to have it on the side. A-B connection. The next one we already said was the 180 here, which is the EC connection. Just write that down. Doesn't matter what order, CE, EC, whatever. Okay, what's the next cheapest number up there? Is it the 205? Am I missing any? Looks like 205, right? 205. 205 is the next. Okay. Is that an okay road to pick? Yeah, it doesn't make a loop too early. Not 3 lines hitting any one city. So that's fine. Now, when I write that one down, that EA connection, I'll go like that, showing that I'm connecting 2 that already exist. I'm not going to write a new EA. I already have E and I already have A on my diagram. Okay, keep going. What's next? What's the next? That was 205. What number's next above 205? Is it the 255? I think that's it, right? So grab that one. Is that one okay? Yeah, it doesn't make a loop. We haven't closed a loop yet, and that's not 3 lines hitting any one city, so that's good. CD, so I'll just put that off of, this doesn't matter what it looks like. You know, you could make them all in a big string if you want. Who cares? It's just showing what's connecting to what. It'll be helpful, especially when I give you a table problem in a little bit. You just know what's connecting to what. I don't care the look of it. So, okay, at this point, let's don't waste a lot of time. We have to connect D with B. I mean, right? There's no other options. Let's don't go through the list of numbers. That actually is the next number, though, huh? Wow, this is lucky. This is for sure the best answer. So, but even if it wasn't, even if this was 10 million, I got to take it. Because those are the loose ends, and we've already been to every city. You got to go home. I would have to take that road. You see, that's why this doesn't guarantee the best method. We're being forced to take that road, whatever it is, even if it was 10 million. But coincidentally, it is the next number. So that's it, D to B, boom, D to B. That's our thing. Add up those numbers, what are those? 155, 180, 205, 255, 310. Wait, did I miss 1, 2? Should be 6 of them, right? 5 cities, 6 connections? Wait, no, 5 cities, 5 connections, right? Did I get them all? Yeah, that's it, yeah. Add them up. Somebody got a total on that? Carry 13, 14, 19, 20. Is it 1105? Did that quick, I don't know. 6, 14, 19, 20, 2. I think it's right. 1105. Okay, and then the same kind of thing. You got to multiply by 8 or something, right? Isn't it 8 again? 6. Oh, 6. This one's $6 per mile times $6 per mile. 66.30 is the total cost of that trip. And there it is. There's the best set of that's now this was a coincidence that it gave us the best answer. It won't always give the best answer. It'll just give a pretty good one. That one's actually the best answer. Used all the cheapest roads. Is that okay? That one worked out a little too smoothly. I'll give you one in a minute that doesn't work out quite that smoothly. Is that okay on that? Cheapest link? So those are the 3 methods. I'll move on if you're okay. So let me show you. All right, suppose that in solving a TSP, that means traveling salesman problem, you use the nearest neighbor algorithm and find a nearest neighbor tour with total cost of $20.75. Suppose that you later find out that the cost of the optimal, what does optimal mean? Best. The best answer was really $17.87. What was the relative error of your nearest neighbor tour? Error equals your, let me write it like I did. Well, it's your value. Here, let me write it clean for you. I can find my notes. There we go. So, yeah, your time minus optimal over optimal. So definitely want to put that in your 3x5 card for the test, because I'll ask you that. So what? Time or money, same thing, whatever. So our time was 20, or our money was 20.75 minus the optimal 17.87 over the optimal 17.87. Use your calculator, and I think you're going to get 0.161. Anybody got it? What is it? Anybody? What comes after the 1? 0.161? 1611? Okay. So yeah, so when you turn, that's the decimal. So when you turn it into percentage, you know it moves 2 places. And they want you to round to 1 decimal place, so there we go. Does that make sense? Do you see how that gives you the error? Because that you take how different you are than the optimal divided by what portion of the optimal that is. Right? Notice if you subtract these on the top, what is that, 13? And so 80, 88? 813. Yeah, 88. So no, doesn't this come out to be, oh, not 88. It's like 288, right?
Yeah.
So over 1787. No, you're off of the optimal by $288. You're costing more than the best. This is the kind of thing UPS FedEx would want to know. Where they would say, hey, look, your little method, cheapest link, nearest neighbor, repetitive nearest neighbor, whatever, got us an answer, and we spent $2,075 on transportation that day to get our packages out. When we found out later, somebody else found the best answer, really would have, there was a better loop out there that would have cost only $1,787. What percentage error was that? Well, it was off by $288. What percentage of the best answer is that? What part of? See how that's a percentage? Whenever somebody asks you, I would say, what percentage of the class is going to get A's? Well, maybe 4 people divided by 16, right? That'd be 25%, right? So you take the part over the whole. That's how you do a percentage, right? So I'm saying, what part is it off? It's off $288 from the best answer. What part of the optimal answer is that? It's 16% of the optimal answer. It's off. You know, we're over cost. We're in error. We did not pick the best answer by a 16% error. Does that make sense? That's what that's telling us? It's a 16% error. So the point they're trying to make is none of these methods are perfect. There is no perfect one yet found. None of these methods are perfect. They all do a pretty good job. Remember, the computer would take 800 years to find the perfect answer. So we use these methods, cheapest link, repetitive nearest neighbor, to find a pretty good answer. And we would like to know, FedEx, UPS, whoever uses this would like to know, well, how pretty good is it? Well, in this case, it's a 16% error. Cost you some money because it's not the best answer. So that's why they search, that's why they pay engineers and people like that to find them good ways to deliver their packages. Make sense on that? Just time minus optimal over optimal. Try another one. Thing. So suppose find best cost, an optimal, yeah, so same kind of thing. Error equals your time or your cost, same thing, minus optimal over optimal. Okay, and they're saying you find, and the cost is $15.96, so that's your time, your cost, whatever. And the error was 6.4%. What was the optimal? Well, do you realize they're giving you the error now is 6.4%. Turn that into a decimal, 0.064. The time, or the cost, is $15.96. Minus, I don't know the optimal, call it X. Solve the equation for X. Let me slow down there, and then I'll show you some algebra. Did everybody see what I did there? So far, so good. They gave me the error, 0.0, I changed it to a decimal, right? 6.4%, moved the decimal back 2 places. And they gave me my time, my cost, same thing, $15.96. And they're asking me for the optimal. They're saying, what is the optimal? So I call that X, right? It's in 2 places. Call it X in both places. And solve that equation for X. Now, how's your algebra background? How do you solve that little equation for X?
Multiply both sides by X.
Yeah. Or you could just put this over 1 and cross multiply. I found that's easier for students, but you're totally right. Isaac, right? You can just multiply by X or cross multiply, same thing. Right? So what does that mean? It'll be 0.064X is 1 times 1596 minus X. Everybody see what I did there? Remember that from your algebra days? Those glorious algebra days? Were those glorious days for you? All right, cross multiply. Boom, boom, like that. Boom, boom. Right? Or multiply by X, same effect. Totally, you know, if you multiply by X, see how it's going to be exactly the same thing. These will just cancel. This is X times 0.2064, same thing. 2 ways of saying the same thing. Okay? And now, just distribute, and 1, that's not going to do anything. So bring it up here. 0.064X equals 1596 minus X. So far, so good? That one multiplied didn't change anything. Okay? And now, we got the X in 2 locations. How do you solve an equation, you remember from algebra, when you get the X in 2 locations? Got to get rid of one of them. So add x to both sides. Bye-bye to that one, right? What happens on the other side? What is the other side? What is 0.064x plus x? Remember like terms? Remember 2x plus 3x is like 5x, right? So this is 0.064x plus 1x, isn't it? There's really an invisible 1 there. So it's 1.064x. Just add the 1 and the 0.064. We good to there? Last step to get x alone? Divide, right? By the 1.064. And that must be that 1,500 answer where I'm looking at. $1,500 must have been the optimal solution. You okay with all that algebra? Put that whole thing on your 3x5 card if you want. If that helps you. Practice it a few times on your own. See Aaron if you're rusty on that. He's there for class on Monday and Tuesday and Wednesday, 3 days before we take our exam. All right, I'm going to move on. If you're good. It's number 6. So number 7 says, how many edges in K9 and da-da-da-da-da. Remember, I gave you one formula yesterday. Let me give you another one. So in where I write it over here, Kn, here's I'll just give you a couple formulas. Put these on your 3x5 card. Kn, which is a complete graph. Remember what that means? Complete graph in cities. Remember, complete graph means every city connects to all the other cities. So complete graph within cities. What about it? Well, the number of circuits, loops, we did that yesterday, n minus 1 factorial. The number of edges or roads is a little different. It's n times n minus 1 over 2. So there we go. So there's the two formulas. I put those on your 3x5 card, along with the error formula. Number of circuits, number of edges. So it's a way to find how many different loops. Remember, a circuit, this is exclamation out here. It's getting kind of weird looking. And so right, circuits is loops. And edges is roads, right? Okay. So with that in mind, what do they want? How many edges in K9? For K9, it's n times n minus 1 over 2. Plug in 9, so that's 9 times 9 minus 1 over 2. 9 times 8 over 2. That's 36. That's how we got that answer. Does that make sense? For K9, I plug into the formula for edges, n times n minus 1 over 2. So that's 9 times 9 minus 1, 9 times 8 over 2. That's 72 over 2, it's 36. Then for K11, again, it's n times n minus 1 over 2. Plug in the 11. Plug in the 11, it's 11. Times 11 minus 1 over 2, it's 11. Times 10 over 2, it's 55. Is that good for those? Just plug them in. So if you got that formula on your 3x5 card, they ask you, hey, a complete graph with 9 cities, how many roads, how many edges? Just plug into the formula n times n minus 1 over 2. They ask you how many loops, how many different possible loops are there, hitting all the cities, n minus 1 factorial, right? We went over the factorial button last time. Good. And then what does part C say? Oh, just subtracting those? That's kind of dumb. Okay. C just wants you to subtract those. Oh, wait. Does it? What is it? Oh, no. I'm going to have to go to a new page. You're okay if I flash off this page? We got that. I'm going to go to part C over here. I'll do part C. I didn't read it. So up here it says X is K31. Y is K32. Subtract them. All right, whatever. So they just want me to figure out K32. again, it's n minus 1 over 2. So plug in the 32. 32 times 32 minus 1 over 2. I have no idea. Somebody got that? 32 times 31 over 2. It's too big for me. 480 and 16. 496. Oh, is that what it is?
Just 496.
Oh, it's no O. I'm just throwing an extra O on there, huh? 496, thank you. And then K, the other one they want is K31. Yeah, they want K31, which again is n minus 1 over 2. Plug in the 31. 31 times 31 minus 1 over 2. 31 times 30 over 2. I don't know. 15, 450, 465. Okay, and then it wants you to, see it says y minus x, just wants you to subtract those. That's all it wants you to do. Kind of a strange thing. So they want you to take 496 minus 465, and you get whatever you go, 31 as the answer says. Is that good on that? Just wanting you to plug in and subtract them. All is well? Can I flash off of that one? It's number 7. One more in this section. Two distinct Hamilton circuits. In each case, find n. Okay. So, okay, they're saying find n if Kn has two distinct Hamilton circuits. What are they talking about? Well, remember for Kn, the number of the number of circuits, I should say, the number of circuits is n minus 1 factorial. The number of edges is n times n minus 1 over 2. So in part A, they're talking circuits. Part B and C, they're talking edges, different formula, right? So part A, they want me to use n minus 1 factorial. And they're telling me the answer came out 2. 2 circuits. So in other words, they're saying, in each case, find the value of n. What is n? Find n so that n minus 1 factorial comes out to equal 2. Does that make sense to the question they're asking me? Not 2, 3. No, 2, 2. Right? See what they're saying there? Am I losing you in the verbiage there? See how I'm coming up with that over here? They're saying find n, right? Find n so that it has 2 circuits, so that the answer is 2 circuits. So find n, what n could you put in here so that this will equal 2? That's what they're saying, right? Whenever you plug in, like if I plug in 5, for example, it'll be 5 minus 1 factorial, which is 4 factorial, which is 4 times 3 times 2 times 1, which is 24. It's a bunch. Somehow they're saying they got an answer at 2. What n value did they plug in to get an answer of 2? Do you see? Am I losing you? They plugged in 3 here, didn't they? Because that came out 2 factorial, which is 2 times 1, which indeed is 2. So 3 must have been the n value that was plugged in to come out with 2 as the number of circuits. Right? Do you see that? So that's why n is 3, is the answer to part A. We okay? Can I move along from that? Now, let's try B and C. My method for B and C is going to be guessing. I mean, I could show you a fancy algebra formula, but it's easier just to guess. So let's do B here. So B is saying, hey, I want the K-in formula. Now we're talking edges now, not the circuit one anymore, the edge formula, n times n minus 1 over 2. And you want that to equal 66. That's what they're saying. It comes out 66. Find n. Find the n you can plug in there to make that come out 66, the edge formula. You guys tracking with me? So, guess. Guess at 10, for example. Doesn't matter. It'll tell us whether to go higher or lower. If you plug in 10, you're going to get 10 times 10 minus 1 over 2, which is 10 times 9 over 2, which comes out 45. Too low. So go higher. How we doing? Am I losing you? See what I'm doing? I'm taking this formula. I'm saying, they're saying, hey, it came out 66 edges. I want it to come out 66. What in value, right? They're saying what? Now I know the answer is right here, but I'm pretending I'm not looking at that. I'm not looking at there, ignoring that, right? I'm just guessing at 10. It came out 45. That's too low. So I go, okay, let's go to 13. 13 times 13 minus 1 over 2. What's that? Well, it's 13 times 12 over 2, which is 16, 18, 78. That's too high. Too much. This other one's too low. So it's n equals 10 comes out too low, 13 comes out too high. Try 12. Obviously that's going to work. 12 times 11 over 2, 66. Bingo. So n is 12. Does that make sense? I think I could show you a formal way, but it's hard. The algebra is pretty messy. So just guess. That's going to be the easiest thing to do. Just guess at it. 2 or 3 guesses with your calculator, you'll have it. Is that okay? On that? Same thing for part C. Just guess. Even though it's big, just guess. Take that formula, plug in numbers until you get 19,000, whatever that is. Edges. Go higher, lower. Like playing warmer, colder, right? We good with all that? Questions I can answer on that? Because now I want to go to the problem. All right, let's give it a go. So, okay, so we haven't done one like this in the homework. Here's a mileage chart. First off, is it making sense what the thing's even saying? What I mean is, like, let's just go through. What is that 795 right there? What does that even mean? Miles. Yeah, how many miles from where to where? Atlanta to Dallas, right? Because it's where Atlanta and Dallas meet. So that means there's 795 miles to fly from Atlanta to Dallas, right? And 1398 from Atlanta to Denver, and on you go, right? See how all the numbers are repeated the same? Because Atlanta to Dallas is going to be the same thing as Dallas to Atlanta, right? So there's a repeating of all the numbers. Okay, so it's just a chart how far from city to city, okay? So it's a table instead of a picture. But we can still do all the same methods to find the cheapest way. So here's their question at the top. Traveling saleswoman's territory consists of the 6 cities shown in the following mileage chart. The saleswoman must organize a round trip that starts and ends at Memphis. Notice that. That's her hometown, right? And will pass through each of the other 5 cities exactly once. The nearest neighbor algorithm applied to this problem yields the following solution. So they're saying, do nearest neighbor on this thing. Now, notice it does not say repetitive nearest neighbor. It just says nearest neighbor, not repetitive, right? Not repetitive. Everybody seeing the difference between those? It's just nearest neighbor. It's not repetitive. So notice I'm not going to start at every city and do the whole thing. I'm just going to start once and do the nearest neighbor every time. Where am I going to start? Start only at Memphis, where they told me to start. That's her hometown, right? Memphis. So basically they're saying, hey, start at Memphis and do the nearest neighbor thing. Okay, let's do it. So I'll do it up here. Starting at Memphis. This is going to be nearest neighbor. Nearest neighbor. Start at Memphis. If you're at Memphis, I'll look right here across. If you're at Memphis, which city is closest to you? Who's your nearest neighbor? The 371, huh? That's Atlanta. Atlanta is the closest city to you, right? Is that making sense? So I'm going to go Memphis to Atlanta. Good so far? If I'm sitting in Memphis, the closest city to me is Atlanta for 371. So try the next, so let me give you a little bit of time. So now go to Atlanta and find out from Atlanta what the closest city would be. So from Atlanta, which one of these is the lowest number? We can't do Memphis again, so we can't go right back to Memphis. It would be Houston, I guess, right? Houston. So Houston. Okay, now you're at Houston. Now from Houston, what's the nearest neighbor from Houston? Yeah, Houston. Yeah, Dallas for sure, huh? Dallas. So now we're at Dallas. So now look across to Dallas. Who's the nearest neighbor now? Well, it's Houston, but we can't do Houston. Who's next? Memphis, but we can't do Memphis. Kansas City, huh? Kansas City. At this point, we've done all but one city. Remember when we've done all but one, don't waste a lot of your time looking at things. You got to go to that last city and you got to go home. Everybody with me at this point? So what is that last city? Oh, Denver, yeah, Denver. So we've got to go, because there's 6 cities, huh? So always know how many cities you got so you know when you got only one more. So all we got left is Denver. Whatever it costs, we got to go to Denver, and then we got to go back home to Memphis. So there's the route that the nearest neighbor method would give. It's not necessarily the best. There may be a better way out there. There probably is. But that's the answer that the nearest neighbor method would give us. Which one is that? Memphis, Atlanta, Houston. Is that C? Memphis, Atlanta, Houston, Dallas, Kansas City, Denver. Yep, it's answer C. It could have been listed backwards, though. Watch out. On the exam, they could have listed it backwards, right? Meaning Memphis, Denver, Kansas City, Dallas, Houston. It could have been the other way. It's the same loop. So watch out for that answer. It's the same loop. We good with that? Because we'll do 21 if you're okay with that. I want to do one more of these cheapest link. We've only done one, and it came out unnaturally easy. So if you're okay with that, I'll go to a fresh screen, and we'll do cheapest link, which is a little bit harder with a map. I mean, without a map and a table instead. So now we're going to do cheapest link. Let's try it. So I'm in 21 here. Cheapest link using. So let me let you start, rather than me diving in. Can you do the first step there? All right, let me help you get started. So what do you do? So we're trying to do cheapest link now. Write it up here. Bless you. So with cheapest link, what do you do first? Do you start it, because we're supposed to start at Memphis, right? Memphis or hometown. Does that mean I start at Memphis and just look across and pick the lowest of these numbers? No. I hope that's coming across clear. With cheapest link, you look anywhere. We'll eventually bring Memphis in, but that's the main difference between cheapest link and all the nearest neighbor stuff. Nearest neighbor, you're pinned down at one city, only looking from that city. Cheapest link, you look everywhere, right? Look everywhere. That's the mistake I've seen over the years that students make. They get confused. Do you see that difference? Cheapest link is like you look at the whole map and pick the lowest number anywhere, right? Anywhere you want. So what's the lowest number? And not just from Memphis. I know we have to eventually form the loop starting from Memphis, but that's later. Again, I think they get confused. They look at these answers and go, they all started from Memphis. I'll start from Memphis. No, they just rewrote them starting with Memphis. That doesn't mean that's how they found them, and that will mislead you, right? Just look for the lowest number anywhere. So what's the lowest number up there?
243.
Is it? I can't even see that one.
Houston.
Oh, there it is. 243. So yeah, so we want that one right away. So I'm just going to go Houston, Dallas. I better put DA for Dallas to distinguish it from Denver. So Houston, Dallas. I'll just write Dallas. Houston, Dallas. I'm going to remember write, especially with this table, it's want to write the links you're making. Houston, Dallas. Okay, what's the next cheapest number? By the way, let's just cross off this part or the bottom, whatever. You don't, because all the numbers appear twice, right? You don't want to confuse yourself. I'll just get rid of half of them, just because they all appear twice. I'll just look down here. What's the next cheapest number? Is it the 371? Yeah, it looks like it, huh? I don't see anything lower. That's a little bit easier, right, to only look at half of them? 371. That's Memphis, Atlanta. So I'll just write MA. Memphis connects to Atlanta. You can write AM, MA, whatever the order. Doesn't matter. Is that good? Can you find the next cheapest number up there? Which number's next? 451. That's Memphis, KC. So I'll go Memphis to K. So I just went down. You can go across, whatever. I'm just keeping a track. Hey, have we violated anything yet? Remember with the cheapest link, you just keep picking roads, links, but you be careful to make sure you don't violate what two rules? Too early of a loop that closes itself without using all the cities, or 3 roads, 3 connections hitting one city. Don't do those 2 things. Otherwise, keep going. So after the 451, what's the next number? 452. Can we take that one? Yeah. That's a Memphis, Dallas. So if I make the Memphis, Dallas connection there, see, I just did M to Dallas. That's a no-no. Why?
Because Memphis is already followed.
That would be 3 connections to Memphis. See how that's a no-no? This is our first no-no on a cheap link, so I want to pause here for a minute. Does everybody see that? So what you do then is you just cross off the 452 to know that you've looked at it, but you can't have it, because it would make 3 hits on Memphis, and that's not reality. You're making a loop, right? Which means every city you're just going to come in once and go out once. You're never going to be hitting it 3 times. That won't make a loop. So you cannot do a Memphis-Dallas connection. So skip the 452. Go to the next number. Is it 489? Is that it? Yeah, looks like it, huh? Be careful on the real test. Oh, whoops. Can I do 49? Is that acceptable? That's a Kansas City, Dallas connection. Kansas City, Dallas. Is that okay? Yeah. I haven't made a loop yet. That loop is still open. It's not closed. Right? Haven't made a loop yet. And there's no cities hitting 3 times, so that's good. Take the Kansas City, Dallas connection. All good? See how my little map over there tells me that everything's okay? That's why you need to be making that map as you go. Who could even tell by these circled numbers, you know? But you want to make the map as you go. What's the next cheapest number? Isn't it 561? 560. Can I take 561? That's a Memphis, Houston. Memphis, Houston, right there. Is that okay? No, that's 3 hits. See that? If I do Memphis, Houston right here, that's 3 hits on Memphis again. No, can't have that one. Cross off the 561. Keep going. What's the next one? Isn't the next one 600? I don't think I'm missing something, am I? 600. Can we have that number? That's a Kansas City, Denver. So Denver's not here yet, so I'll just connect Kansas City to Denver. Is that okay? No. 3 connections on Kansas City. See, that's a no-no. That'd be 3 hits on Kansas City. It's only 2 hits on a city. Everybody see the problem? Why I can't take Kansas City, Denver? The 600? See right here? That'd be 1, 2, 3 hits on Kansas City. Can't hit any city 3 times. So get rid of Kansas City, Denver, cross the 600 off your list, and keep right on moving. What's the next number? Yeah, the 710. Oh, that's Kansas City, isn't it? Isn't it that one? Am I missing one? 710 Kansas City, Houston. Oh, but we can't do Kansas City again. That'd be 3 hits on Kansas City. Cross off the 710, can't do that. What's next? 789. Right there, Houston, Atlanta. Oh yeah, that'll do it. Boom, we're done. I made a loop. Oh, no. That's a premature loop. We don't have Denver yet. We can't do that. That's a premature loop. Do you see that? We're breaking all the rules here. This is good. I wanted to show you how the cheapest link rules work. I can't take that one either. Does everybody see that? Right? Houston, Atlanta. I just made this Houston, Atlanta connection. That forms a loop, and we've never been to Denver. It's a premature loop. It's a no-no. Okay, get rid of that. Can't have that 789. What's next? 798? No, 795. Dallas, Atlanta. Is that okay? Yeah, that'd be 3 connections. This is getting a little old. Hey, am I right? Yeah. We only have 1 city left, right? Denver. And we've got 2 open ends of the chain. They've got to hit Denver, don't they?
We skipped 789.
Do we? Did I skip one? Denver, Dallas. Yeah, I can't do that though, right? Because Dallas can't hit Denver. That'd be 3 connections on Dallas. But thanks, I did mess that up. You're right. Hey, yeah, let's stop fooling around. We have 1 city left. I should have noticed that. We have 1 city left, and we got this chain that has 2 open ends. Right? We're making a loop. We got 2 open ends, and we got this one thing we're supposed to go to. Well, connect them up. You're done. Right? Who are the open ends? Houston and Atlanta. They're open ends, right? They're the ends. So write Denver wherever you want. I'll just put it out here. And boom, boom. They both hit Denver. There's my loop. That's a loop now, right? So it's got to be those 2. If that bugs you, squeeze Denver in the middle between them, you know, whatever. Put Denver here. Boom, boom. Is that better to look at? There we go, however you want. But you got it. I shouldn't have wasted all that time going through those numbers and saying, no, right? When you got 1 city left, the open ends, hit that city, you're done. That's all 6. Isn't that 6? That's all 6 cities, right? Yeah. So there's the answer by 2. Now, what is that? We got to rewrite it starting with Memphis, since they wrote all the answers in that loop. starting with Memphis. How do you write it starting with Memphis? Well, you can go two ways. Start at the M, and I'll go this way. I'll go MK. Right, I went MK, follow it, Dallas, Houston, Denver, Atlanta, back to Memphis. See what I did there? Now I could have gone the other way. I could have, but it's the same thing reversed. Which answer is it? Isaac says C. Memphis, Atlanta, Denver, Houston. Memphis, Atlanta, Denver, Houston, Dallas, Kansas City, Memphis. Yep, it's backwards of the way I went. It's the same answer. Does everybody see that? This is that. Everybody see? Remember, forward, backward, same circle, right? So that's a little harder. Is everybody good with that cheapest link thing with the table? Does that make sense? So I just started picking numbers. And as I went, I had to follow the rule, don't close a loop prematurely. Don't close a loop without all 6 cities in it. And don't have 3 roads hitting any one city. And when you got down to only 1 city left, just take those 2 open ends and connect to that city. Again, that's not the best overall answer. You can tell we skipped a lot of good roads. But it's a pretty good one. This method does a pretty good job of giving us a, would save some money. UPS, FedEx, salesperson traveling. Right? It would save some money. It's not the best answer. Computer takes 800 years. Get the best answer. It's a complex problem. Good? Questions on that? Right? Good. So I'm going to leave this. Well, actually, I want to do one other tiny thing. And that is, I don't think I told you. Yeah. Last thing in this chapter. Then I want to start the next chapter. We definitely need to spend a good half an hour in the next chapter. These methods. Okay, so what were the methods? Here's the chapter 6 conclusion. So we're done with chapter 6. Here's the conclusion, which will be asked on the test. These questions: the nearest neighbor method, the nearest neighbor, repetitive, nearest neighbor. And cheapest link, all the 3 methods we learned, all of those methods are approximate, meaning not exact as best. They don't give you the best answer, but they're what we call efficient. Meaning they're fast, at least for computers. Sometimes they take us a while. But if you program computers to do these methods, they'll crank out your answers lightning fast. They won't take 800 years. The computers can do these methods super fast. The only other method is called brute force. I don't think I even used that word. That's where you list every possible circuit or loop. Right? You just look at every one. You just have the computer do every one. That is an optimal method, meaning best answer. You will get the overall best answer if you look at every possible loop. But the problem is, it's, do we just say inefficient? Is that the word? Yeah, I guess we do. It's not efficient. It's super slow. Years, even for the supercomputer. So there's the story. Well, is there a method out there that gives the best answer and doesn't take years? Nobody knows. It hasn't been proven to not exist yet, like those other chapters. Remember the other chapters? It had been proven that no such perfect voting method or perfect apportionment method exists. Well, nobody knows. Mathematicians still search. Maybe there is a better method out there. So that's the state of science when it comes to managing, visiting a bunch of locations. So you will be asked questions like, the repetitive nearest neighbor method is A, efficient. B, inefficient but approximate. C, then, that kind of thing. So put this on your 3x5 card. It's pretty simple. All of them are approximate and efficient, except for brute force, which is not efficient yet optimal. Gives you the best answer. We call all those the lingo in the math science world. These are all called algorithms. All these are different algorithms. Algorithm is steps to do anything. Like a recipe. A recipe is technically called an algorithm. Bless you. So it's just a fancy word. Just recognize that word. It just means recipe, just a bunch of steps to get something done, right? But the math science world calls it an algorithm. So the nearest neighbor algorithm, the repetitive nearest neighbor algorithm, the cheapest link algorithm, the brute force algorithm, meaning method of steps to go through. All right, chapter 6. I'm going to leave that, if that's okay.